Hi everyone, and welcome to lesson 3 of our Programming with Python series with the DreamSpace home space. So you're very welcome to today's episode. We're going to continue on what we've learned in the last 2 weeks today. Joined again today by Damien. And in the background, as always, we have the team as well that are there to answer any questions that you might have on the Q&A panel. So as you go through today, remember you can ask questions. We always say this, but we're going to keep saying it. Remember, you can also pause the webinar at any point so that if you're kind of trying to catch up or if you want to check something in your code yourself, you can pause us, go off and do that and then come back, because we are aware that we introduce new things every day and every episode, so it can be hard to kind of keep up live. You might need to pause every now and then. Okay, so last week we finished up after kind of covering a lot of new information by setting a home challenge. And the home challenge was basically that you would develop a program, and the program would ask you to enter a subject and then enter a result for that subject. And we wanted you to do that for 3 different subjects, okay? And then when you had those 3 results, we wanted you to calculate an average of those 3 results. And then finally, we wanted that to all be printed out in a table. So when you first read that, you know, I know when I first read it, there was a lot going on. So I sat down this morning to do this out in Python myself. And before I did it, I quickly just wanted to jot down what I was doing. And we talked about this last week, that we should be able to map out our program. So what I have here is the idea that, okay, I need a user to enter a subject and then enter the result for that subject. And I'm going to do that 3 times. Now, that is technically going to be the same kind of code. Okay, it is going to be slightly different to write with our variables. But if we were clever about this later on in the weeks, we are going to introduce loops, aren't we, Damien?
Yeah, that's the hope. Yeah.
So in that instance, what I do today actually might seem quite long-winded if you're familiar with loops. But when we kind of learn about loops, then we can come back and we can iterate over these programs and make them more condensed and make them better, okay? But for today, this is what I'm going to do. I'm going to get the user to do the subject, the result, the subject, the result, the subject, the result. And then remember, I'm going to then get my computer program to calculate the average using those 3 results divided by 3. And we talked about maths operations last week, so we're going to bring that into play here. And then finally, we're going to get that printed in a table. Okay, so I'm going to hop into my notebooks now. So if you haven't logged in yet, you can go and log in. And I'm going to work my way through this home challenge. If you did it at home, you can be checking. You might have done things slightly differently, by the way. That's always the way. And even myself and Damien probably did this slightly differently. But if you didn't do it, you can even go along with me just to, again, refresh the memory over all the different things that we wanted you to touch on with this home challenge, okay? So I'm going to hop out and I'm going to go into my browser. And I'm going to go into my notebook here. So just make sure we can see this. I might zoom in slightly. There we go. Okay, so I've used my hash symbol here just to kind of, again, write out the steps of what I want to do. So the first thing I want to do is the user needs to enter a subject and a corresponding result. Okay, so the first thing I'm going to do is I'm going to go back to my print statements and I'm going to print in the question. So please enter your first subject. Okay, so that's the first thing that the user is going to do. First thing the user is going to see is my print statement. And then they're going to have to remember, give me this answer. So that is an input, okay? And I'm going to store that input in a variable, and I'm going to call that variable subject1. I'm going to use my camel case we talked about last week. So subject1 equals. Now, Damien, a subject is going to be, last week we talked about data types, didn't we? So
yeah,
the subject is going to be a certain type of data. Which data type are we looking at here?
So it'll be a word, so it'll be a string.
A string, yeah. So guys, remember, we're not just saying subject1 equals input. We want to maybe just call out the type of data the user is going to put in here. So I'm going to use my string, or str, okay? And then I'm going to do my bracket, open bracket, and then I'm going to do my input, okay? So that should work. Now, just to double check, I'm going to run this just to test it. Okay, please enter your first subject. Perfect. And I'm going to say English. And it's working. Okay, happy. Now, that's the first part of my thing. The next thing, remember, was it for it to get the result, okay? So what I'm going to do is when the user enters English or this first subject, I'm going to print and say, thank you, please enter the result for this subject. Okay. And now again, we're going to need an input from the user, okay? So I'm going to call this result 1, all right? So Damien, last week we talked about, obviously a result is going to be numbers, and we talked about two types of data that can, two data types, I suppose, for numbers. We had our integers and our floats. Which one do you think in this instance is going to be best?
So I think an integer will be fine here. Like if it's a result, it'll probably be a percentage, and usually percentages are going to be whole numbers.
Yeah. So a teacher might calculate it with, you know, with floats. They might have decimal places, but typically when a student receives the result, it's going to be the whole number.
They've rounded it up or down. Yeah, so it'll be the whole number.
Okay, so what we're going to do is we're going to do our integer, okay? And again, remember, this is going to be an input from the user, okay? So we have our int and input. So let's just check that this works. There we go. So it's come up, and I'm going to say English. I'm trying to think back. I'll give myself 72, right? Okay, there we go. And we can see that's working for us. Okay, perfect. Now, we're doing this, remember, for 3 subjects. So like I said before, when we go to condensed code, there will be a way of us kind of doing this within a loop. But for the moment, we're going to do them as all separate, okay? To speed this up, I am going to copy and paste my code, all right? But I'm going to obviously have to change and tweak things here. But I'm going to take this whole, these 2 lines, and I'm going to right click and I'm going to copy. And I'm going to come down here and I'm going to right click and I'm going to paste. Okay, now obviously this is my first subject. This is going to be my second. So now I'm going to just go and amend my code, but it just saves me writing it all again. Okay, and my variable in this case is not subject 1, it will be subject 2. The string is still going to be, the input is still going to be a string. So I'm going to leave that data type is correct. All right, and then I'm going to do the same for this. I'm going to take my result lines and I'm going to copy them and I'm going to paste them in here. And again, this makes sense. Thank you. Please enter the result. But remember, it's not result 1 anymore. This is result 2. So it's important that your variable names are changed here, guys. If you are copying and pasting it, it's not a rush job. You still have to really read it, because otherwise, if you didn't change the variable name, it's going to update what result 1 was, for example. Remember, it stores and it will change as it goes. And I'm happy with that. So I'm going to run that. So I did English. So I'm going to do Irish. And by the way, sorry, Damien, you've been clicking run, haven't you?
Yeah, that's usually how I run the program.
Yeah, so you can click run. The reason mine is just happening, sorry guys, is because I'm hitting shift and the enter key. Okay, so I'll click run this time. So Irish, sorry, need to enter that. Okay, and now we want our result for Irish, so I'll click run and I will say 63. Okay. Okay, perfect. So that's 2. And again, we're going to do the third one. So we're going to just copy and paste again. Please enter. And again, we're changing this accordingly. It's the third subject. And this time we're going to say subject 3. Perfect. I'm going to run that. And I'm going to say maths. Okay. And then lastly, we want to get our result for maths. So we've got 1 whole subject, we've got 2, and then we need to get the result for the third one. So I'm going to copy and paste this. Now, one thing actually we could do, Damien, isn't it? If I have here print, thank you, please enter the result for, I could actually, if you wanted to be really kind of specific with your program, we could actually delete this, couldn't we? And we could put a comma in, and I could actually write subject 3, couldn't I, Damien?
Yeah, and then they'd know exactly what subject to enter for.
Exactly. So if you want to, you might have done this already, or you might not. It's just to show you there's alternative ways of doing things. I could actually say print, thank you, please enter the result for, and that's my string. And then I'm going to call on, they're going to get the variable here. So I have subject 3 is my variable that's been stored, so maths, and it should actually say, please enter the result for maths, okay? And then again, it's going to be an integer that I enter. So let's just run this and see if it works.
Just
there you go. So, yeah, so there we go.
Your result 2 there, you might need to change your variable name.
Oh, there we go. Thank you. Thanks for spotting that one.
Perfect.
Yeah. So result 3 is exactly it. So I was in a rush there. I was getting all happy that we were going to shorten our code here. Perfect. So result 3. Thanks, Damien. So we'll run it again now and just make sure it's okay. I think maybe we need to restart the kernel. Yeah. Okay. Sorry, guys. 1 sec. So we talked about this last week. When you see this little asterisk, remember, it isn't running. So I'm going to just quickly restart this for a second just to make sure it's refreshed. And we will try run it again. Give it a sec. Saying kernel ready. We'll try that again. Oh, I have a bug. Oh, okay. So actually, yeah, I'll point out what this is saying, guys. Basically, it's saying subject tree is not defined, and that's because I restarted this area and I didn't run this one again. So basically, what's happened is it doesn't actually know what subject tree is because all I've done is rerun this this kernel, and it doesn't actually know, if that makes sense. Does that make sense, Damien? So yeah. I need to actually, what I need to actually do now is rerun this, okay? So I'm going to run where I've kind of defined subject 3 again, and I'm going to have to enter maths again. And now when I rerun this one, there you go. So that's all the bug was. So that's why it is useful, the little blurb it gives you, always read through it. It does normally tell you where the error was, so kind of clear enough there. Okay, so please enter the result for maths. So I'm going to go 70. Okay, and then that one is done. Okay, so what we've done there is we've got the user to enter 3 different subjects, and we've got results for each of those subjects. Now, if I look back up at my comments at the top that I had broken down what I wanted to do, that's the first one. The next one was that, sorry, this one, when the program's complete, calculate an average. Okay, so we want to get an average of all these scores. Now, this actually is going to kind of introduce something that we're doing today, okay, which is looking at how we kind of organize our maths instructions, okay, with BIMDAS. But I'm going to obviously have to create a variable to do this first of all. So I want to get an average. So I'm going to say average, and I'm going to say average result equals. Now, we want again to calculate an integer of this. Am I right, Damien?
Yeah. Yeah. Well, it could be a float, but I think the computer will figure that out itself as long as you're not inputting it yourself.
Yeah. Okay. So we could actually call out the data type here, or we could leave it because it's already been done with our previous instructions. Am I right?
Yeah.
Yeah. Okay. So what I might do is will I make it clear and say int anyway?
You could. The only thing is, if you're getting the average and you divide by 3, you could end up with a decimal in it, and it could give you an error.
Yeah. Okay. So we'll call out float.
Yeah.
Yeah. Okay. So we'll do float, all right, because this is the data type we're looking at. And remember, what we need to do is add the 3 different results we've just done. Okay, so I'm going to open up a bracket here. Now, this is important because basically we want to add the 3 figures together and then divide by 3. And if we think about the BIMDAS rules that you would use in maths, for example, it's important that the addition is done first before that division. All right, Damien, you're a maths teacher, so you'll be kind of going on, you would talk about this a lot, obviously. So it's important that we put these together. So I'm going to say result 1. So remember what I called my results all the way up here. And I'm conscious that I might need to rerun these actually, but we'll see. Okay, so result 1 plus, and we're bringing back in our operations we did, result 2 plus result 3. Okay, so that's the first thing my program's going to do. And when that's done, when it's added those together, we are going to divide by 3. And we talked about last week, the symbol for division was our / So we're going to do / and 3. Okay, when that's done, then I want to actually just print it out just to see it's working. And we might get an error here, like I said, because we didn't rerun the other bits of code above when I restarted there. So print average results. Yeah, okay, that's fine. So I'm going to quickly have to just redo these, guys. Just rerun these so the program knows exactly. So we had English. I think I gave myself 72. Doesn't really matter anyway. Enter. We had Irish. 63. And then we had maths. Now, we already did rerun this, but we'll rerun it anyway, just to be very, very clear. I can't remember what I gave myself in maths, Damien. I think it was...
I can't remember either, but you would have got pretty high, Amanda.
Thanks. Okay, 65, I'll say. Okay, there we go. So, and now I've ran this one, average result. So it's given me a float. So here's my decimal place that we talked about, Damien, because like you said, when it divides, it's going to be in there. Okay, so we've printed. Now, the last step we had was when we had all of that information gathered, we could see clearly a subjective result, and we had that 3 times. We get our average. We wanted this printed in like a neat table. Now, this is probably the part that would have taken the longest. I know this morning when I sat down, I got through all that quickly, and I got to the table part, and it took me a little while to iterate and replace things. So instead of doing it all now with you, because it does take a bit of time, I'm going to show you how that looks, okay? So you can see this is, I was just in this morning, and then we have all this. So here is what we did for our table. Now I'll zoom in a little bit just to make sure it's clear. So what we're doing is print, and we're just drawing out using our hyphens and our lines, okay? We're just kind of making sure that's a nice clear table. Once I had this done once, by the way, what can we do? We can easily just copy and paste it and put it in underneath each area, then it saves us having to do it and make sure it's always the same. We have print, so we're given a bit of space, then we want to see what subject 1 is, then we're given a bit of space, and then result 1. And we run all these, and we eventually should get the output of our table. Now, the reason I said this takes a little bit longer is I know this morning when I did it, I had to keep adding space. So these lines were all over the place. Like the English line might be here, the Irish line might have been back here, the maths line, and it looked really messy. So I had to go back over it a couple of times and kind of basically use my spacing and understanding of the spaces that are in place here to get it to be actually straight, okay? And so it can take a little bit of time. So it would take me a while to recap on that one with you guys. So what we're doing is very clearly just setting out the table, adding it in, and you might have had to run that a couple of times just to get it the way it looks here with our average results. I went up in maths here, Damien, as you can see. So hopefully that's okay, guys. You can see there was a bit to it. We will, as we go on over the few weeks, we will add to knowledge that will help us condense that code with different bits of information. But for the moment, we are focused on our print statements, our data types, and using our variables to create this program. So really good work if you got that done. Okay, so I'm going to hop back in and pick up where we left off here. Okay, now just to recap over some other things and things we're going to pick on today. So obviously we've seen, and we talked about last week, addition, subtraction, multiplication and division and how they were being used in coding. And bar multiplication and stuff, we've kind of used them a lot, right? Today we're going to touch on them even more. We also mentioned that over the coming weeks we will touch on these other 2 types of operations using the power of. We're going to touch on that one today actually, Damien, aren't we?
Yeah, we'll look at that in a little bit.
Yeah, and then using modulus. Okay, so we will come to them in the next few weeks. Something we want to look at today is talk about how we can do maths and calculate maths problems in a really short kind of space and time. Okay. What I mentioned there, you saw in the home challenge, and that was really important, is to do maths operations properly. We do need to bear in mind the BIMDAS rules that you would use in maths yourself. So even if you were writing this out in pen and paper, what you would have had to do. That's why I used my brackets when I was calculating my average there. Because if I didn't, what would have happened is result 3 would have divided, okay, by 3 before the addition was done. Okay, so we actually would have missed a step there, okay? And the answer therefore would have been incorrect. So it's really important if we want things to be accurate that we follow those rules. Again, we talked about the symbols being different. So that's the only thing we need to bear in mind compared to when you're doing it with pen and paper or with your maths book. In Python, the symbols you use might be different. So what we're going to do, and Damien's going to take you through this now in a second, is we're going to get Python just to work out the area of things. So area is a pretty common maths concept you cover a lot, okay? The first thing we're going to get to do is a football pitch. So 110 meters by 83 meters, and we're going to get Python to calculate the area of that, okay? And obviously, once we define the formula for area once, we can actually reuse it a couple of times. And then we have a pizza as well. So we're going to get the area of a pizza, which is obviously slightly different, okay, in terms of the types of formulas we use. So at home, it should hopefully know the calculations or the formulas for these, all right? So with something like a football pitch, we're looking at the area of a rectangle, which is length by width. And that's kind of the way we're going to have to program. But when we're looking at pizza, obviously it's a little bit different. And what we're looking at is the area of a circle, which is pi r squared, or pi by radius squared. So that's where our power of is going to come in. So Damien, if you want to, maybe we'll hop into the notebooks now and try out these examples.
Yeah, let's take a look. I'm going to grab my screen here. Okay, so we'll try and code up those two problems that we had there. That Amanda said, and it's just building on the maths that we learned last week and kind of using a little bit of that. So if you want to, you could even pause the video now for 5 minutes and even try and program one of those yourselves, and then come back in and see how we did it and see if you're kind of close. But we'll talk through and see how we get on. So just to start off, I'm going to have a print statement that tells the user what the program does. So this program works out the area of a pitch and a pizza. Okay, so if we are getting the area of a pitch, Amanda, you were saying that there's a formula for that, isn't there?
Yeah, the area of a rectangle.
A rectangle, which
was length by width.
Length multiplied by width. Yeah. So I've just put that in as a little comment to kind of remind me there. So if I'm going to get the area there, I'm going to need the length and I'm going to need the width. So I'm going to ask the user to give me the length of the pitch. And when I ask the user, I need to be able to get an input. So we'll have a variable called length equals. Now, the number that was there, Amanda, in the question, can you remember, was it an integer or was it a decimal number?
It was an integer. It was a whole number.
Right, so we'll just use an integer there. So int input. Okay. And then I'll also need the user to put in the width. Okay. Width equals to int input. Okay, so now that we've entered the two values, we got to just do the maths part of it. So we're going to use this formula and we're going to multiply our length by our width. So I'll create another variable called area, and I'm going to call it area pitch. And I know that it's different to the area of the pizza when I do that a little bit later on. And that's going to be length multiplied by the symbol for multiply, Amanda, can you remember?
Yeah, so we used a little asterisk or a star, Damien.
Perfect. Length by width, and then I'm going to print out my answer. So print the area of the pitch is, and then we have our area pitch. Okay, so let's try run this and see if it runs okay. So please enter the length. The length was 110, I think. And then the width was 83.
Yeah.
Great. So I enter in those two values and it tells me that the area of the pitch is 9130 meters squared. And we could maybe put in meters squared at the end to have units if we wanted to. And I'm going to have to take the computer's word for that because I can't multiply those two numbers in my head myself. So that's for the pitch. Now, for the pizza, it's a little bit different. All right, although we're going to kind of use a lot of this again. So I'm going to maybe just copy this and bring it down to my next piece of code. And we might just edit this one a little bit because a lot of the pieces are going to be the same. So for printing here at the start, this is going to be for the area of a pizza. Okay, and my formula for the area of a pizza is going to be pi multiplied by the radius squared. So you might have looked at this formula in school before. Hopefully you will have seen it before. But I don't need a length and a width this time. The only thing I need for the pizza is the radius. So I'm going to change this sentence here to say radius. So please enter the radius of the pizza. We'll make it a bit more clear. And then I'm going to change this variable here to be radius. Now, this part here, I don't actually need, so I can get rid of this part because I don't need to enter any other variables. And the only one we need is the radius. And then down here, area of, we'll change this variable name, pizza, equals to. So here we've got to try and make up this formula now. So this is a little bit more difficult. Amanda, I might ask you, this pi, or the symbol pi, which is like it's a Greek letter. Do you know what number that is?
Yeah, so I think normally it's 3, well, it goes on, doesn't it? But 3.14 is normally where we round it up to it in a float.
Yeah, so we use 3.14 a lot, but actually it keeps going on and on and on, and we'll kind of look at that in a second. And that's going, our 3.14 is going to be multiplied by the radius, but I need to square the radius. So we looked at in our maths symbols that if you put 2 asterisks, you can get to the power of. So this will be the radius to the power of 2, or the radius squared. And that should give us the area of the pizza. So then here, the area of the, we'll change this to pizza, is, and then we'll change this variable here to area pizza. Oh, pizza. Okay, so we'll run this and see how we get on. So it's asking me for to please enter the radius of the pizza. Can you remember, Amanda, what the radius was, or did it even give us the radius?
It didn't actually give us the radius. It gave us that the diameter of the pizza was 18 inches. So we're going to have to just then use our knowledge of I suppose, circles to get our radius, aren't we?
Yeah. So
it's going to be 9, isn't it?
Yeah. So the radius will be half of the diameter. So I'll put in 9 here and press enter. And I'm getting an error. So I must have made a mistake somewhere here. Okay. So let me see here. It's telling me that there's a mistake here in this line. So, and it's telling me that the name radius is not defined. So I must have made a spelling mistake or something here. So if you can see here, guys, I said that the radius, RADIUS, is equal to whatever number I put in here. But then when I put it into my formula, I've mixed up my 2 letters here. So we might just change those. And that'll happen a lot. All right, and it's good to be able to spot those errors and then be able to kind of fix them from the error that they give you. So we'll try and run that again. So I'll put in 9 again for my radius, and it's giving me the area of the pizza is 254.34. All right, and that is exactly what we're looking for. So there's just a couple more examples of how we are using maths in our coding and how it might become useful. And we can see there that we're using the power of symbol in one of our formulas today. All right, so we'll keep pushing on and we'll see how we get on. I'm going to swap back to our PowerPoint now. Let's see. So we've looked at our pitch and we've looked at our pizza. Now, we're going to talk a little bit about libraries. All right, and libraries are really helpful because they are code that's already been written by other people, and it kind of gives you a shortcut to do some stuff. Okay, so there's loads and loads of libraries that we can use, and it's just kind of have an idea of where they are or how we use them that makes them very useful. So inside a library, there's things called functions, okay? And we're going to look at functions a little bit later on in this lesson. But when we use a function, it's a piece of code that's been written earlier on that makes things much easier to use, okay? And when we use a library, we have to import it into our code. Because Python is such a big language, the computer can't know all of it all of the time. So when we tell our Python to import something, it allows us to kind of give the heads up that we're going to need something from this part of code. And there's loads and loads of libraries. And as you go through your coding, if you keep up coding past this video and maybe into senior cycle in school or even into college, you'll use many libraries just to make your job that bit easier. Amanda, we might look at 2 libraries in this lesson.
Yeah, I think because we're on it, I suppose the maths library, there is a library for maths, isn't there? And that would make sense because we're doing a lot of math stuff right now, actually. So that could be a good one to start with. And then, yeah, the random library I see you have there. So 2 really useful libraries actually for us.
Yeah, so there's libraries for nearly everything, guys. All right, and it's just to make the job easier. But the 2 that we'll look at today, just to show how they're used, and once you kind of have an idea of how to use one library, you can use many libraries. So the math library, if you see here, can give us shortcuts to do some maths things, like find the LCM or the HCF. So you might have heard of what those kind of acronyms stands for. So LCM is for lowest common multiple, or HCF is for highest common factor. And you can see down here in the code that it can be very easy to find out those things with these shortcuts. You don't have to write lines and lines of code. You can just use the library, the import math library, and then run it from there. All right. And then there's another library called a random library that lets you just get random numbers very easily. So you don't need to write much code. You just use the library and the code that's already been written in it. So we might jump back to our notebooks and we will just do 2 quick little programs to show you how we can use our libraries. Okay, so we'll jump back here. Okay, so the first one we might use is our math library. So we were using the number here 3.14 for the symbol pi. But actually in the math library, there is a function that gets you the exact number for pi with loads and loads of decimals, and it'll show a few of them here. So when you want to use a library, the first thing that you have to do at the very start of your program is import it. So we're going to import the library called math. Okay. And then once you have imported the library called math, your program kind of knows that, okay, I'm going to have to go and look in this library to find something that I might need. All right. And whatever you need from that library, whenever you need it. So down here, instead of 3.14, I'm going to write the word math.pi. So what this does is it says, okay, I'm going to go to the library called math, and inside that library, there is a function called pi, and I'm going to get that. And that's all we really need to understand, because once we run this, the computer does the rest of the work. It goes and finds this function in the library. So as long as you know,
we'll be explaining functions, won't we, kind of towards the end here. So if you're wondering what the word function means in coding, it's a really useful part of code, but we'll be explaining that a bit more, won't we?
Yeah, thanks, Amanda. Yeah, so like functions, I'm saying the word function and we will kind of talk about that, but it's just a little piece of code that does a certain job. So if I really quickly run this now, just bear in mind, so this was the answer I got when I used the number 3.14. All right, but if I use the symbol pi here, or the math function pi, when I put in 9 here, I'm getting a much longer answer with much more decimal places, because this is after taking the real number pi, not just the abbreviated number that we used. Okay.
Very good.
And then, sorry. And then really quickly, we're going to use the random function again. So I'm going to import random here really quickly. Have to spell it right. And if you want to use the random function or the random library, you can create a random number very easily with one line of code. So I'm going to say my random number equals, sorry, I should have a capital N there just to make it easy to see. And then we're going to use the random library. So that has to come first. Random dot. And then the function inside that library. So the thing, the piece of code that does this job is called rand int. And then inside the brackets, we just put the numbers that we want to work between. So Amanda, if I'm getting a random number between 1 and 6, what does that kind of replicate, or what?
It's like a dice, isn't it? We do this with microbits sometimes, actually, when we do our programming with microbits. And one of the first things we might get it to do is pick a random number between 1 and 6 and show it's like a dice then.
Yeah. So here, when I print my random number and I run my code, it just prints the number 2. So it's randomly after picking the number between 1 and 6, and the number it picked was 2. And if I was to run it again, I'd probably get a different number, and I get a number 1 there. So there's just 2 libraries that make our coding that little bit easier if we want to do some complicated tasks.
So maybe they can be very useful. Pause, Damien, and try them out themselves, because they're kind of useful, and I suppose we will be using libraries a little bit more, won't we?
Yeah, we'll be using libraries a lot, because they just help us a lot. So yeah, it would be a good idea maybe just to pause and just to try and import a library and use that library just to do the simple jobs that are there, or maybe even change the numbers and get a different random number there. So yeah, very useful. Okay, so we'll keep going, guys. We have a little bit more to get to. So there are libraries, and with our libraries, we're going to work through a challenge here, kind of really looking at a little bit of complicated maths. So some of you may have been to America or been to a different country that actually measures the temperature different to Ireland. So in Ireland, we measure temperature in degrees Celsius, and you can kind of see a little map of Ireland here with some temperatures on it. But in America, they use much bigger numbers. Amanda, do you know the name of their units for in?
Yeah, my sister lives in America, so she deals with Fahrenheit, degrees Fahrenheit.
Yeah, and so they use different numbers, and their numbers are much bigger. So how can we compare these, or like, is there a way that we can compare them?
I think there's an equation, isn't there? Isn't there a way of using some maths maybe to convert one to the other?
Yeah, so we are able to convert one to the other, but it can be a little bit tricky to do in your head. So perhaps a computer program or something like that could really help in doing this. So we've got this formula here, which looks a little bit complicated, but for Python, it's no problem to do. So if we look here, C stands for Celsius and F stands for Fahrenheit. So if you want to turn a temperature that's in Fahrenheit, so a temperature from America, into a temperature that we use in Ireland, you would have to get that temperature, take away 32, and then this dot really means multiply. So multiply by 5/9. So we're going to try really quickly to program this to change from one temperature to another. And this would really show. Sorry, Amanda?
This happens a lot, Damien, doesn't it? Because when we think about it, there's apps, like I know I use apps sometimes, and when I log on, they allow me to toggle. I might want to look at Celsius, but I can actually click a button and it will actually show me the Fahrenheit equivalent, or I can enter it. So it's something that actually programmers use a lot, is this idea, because they might use it in apps or websites to help people.
Yeah, that's actually a really good point. So in the background on those apps that you're using, there is code that we're going to write, like what we're going to write now, that is doing this in the background for us. But someone had to write that code in the beginning, and this is kind of how they learn how to do it. So what we're going to do, we're going to try and pull the two things that we've kind of touched on so far together. We're going to get the code to generate a random number between 0 and 100. That number, whatever number it gives us, we're going to let that be a Fahrenheit temperature. So it's going to be like a temperature that's in America. And then we're going to try and put this formula into our Python program to turn that Fahrenheit temperature, that temperature from America, into a temperature that we would use in Ireland. So we'll give this a go and we'll see how we get on. So I'm going to jump back to our code here. And I'm actually going to continue on here because we've imported random. So I'm going to kind of use this because we're going to have to generate a random number. But the random number that we wanted was not between 1 and 6. We're going to go between 0 and 100 this time. Okay. Then I'm going to get rid of this line and we'll keep going from here. So now with this random number that I have, this random number is going to be my temperature for in Fahrenheit. So I might just put a different name here, temp, and I'm going to say Fahrenheit or far after it. So temp far, that is my temperature in Fahrenheit. And whatever random number I get there, that's what I'm going to use. Now, that formula that we had on the last page, so it said that temperature in Celsius is equal to. Now we have to think of BIMDAS. We're going to have to do the brackets first. So we'll put in our brackets. Temp var minus 32. So that's going into our brackets first. And then what we might do, I might just jump back here to see the formula. So that's going to be our temperature in Fahrenheit minus 32. And then we're going to have to multiply that by 5 over 9. Or 5 over 9, that really means 5 divided by 9. So what I might do, I might put this fraction into a bracket in my code and then multiply them together. So we'll try and do that. So it's going to be multiplied by bracket, and then I'm going to have 5/9 in my bracket, and it'll multiply those together. And then finally, we might just print out our answer. So the temperature in Celsius is, and then we'll just put in our variable, temp. So,
Damien, I think in your variable name for temp var, I think you just need to swap your H and an A.
Oh, yes. Thank you.
No problem.
FAHR. Thank you. And what I might do, so we'll try and I might just print out here just so I can see that number. So temp var, we'll print this out here. So we'll see the random number that we get, and then we'll see if we get it changed. And I just see I've made a spelling mistake there. TEMP, temp cell. Okay, we'll just try and run this and see. So the random number that I get for my Fahrenheit temperature is 48. And then when we change that into Celsius, we get 8.8888889, and it keeps going on. But we can see that it's changing from one to the other, which is very useful. Yep. Any questions on that, Amanda, or we're good?
No, I think that's really clear. If people want to pause maybe and try it out themselves, but it's really interesting to see. It's only a couple of lines of code really, and it works perfectly. Yeah,
so it is. It's quite short, and that's kind of what we're looking for when we code. We try and keep our programs short, as short as we can, that they still work properly. Okay, so that's kind of as complicated maths as you can kind of be asked for at the moment, guys. That's working with difficult numbers and doing difficult conversions, but it's a great thing to be able to do. And then finally, the last thing for today, we're going to just touch on functions. All right, so we talked a little bit about functions a minute ago, that they're in libraries, but we can actually write our own functions if we kind of need to. So functions in Python or in any code allow us to put a little job inside a piece of code that we can use over and over again, so we're not really repeating ourselves. Okay, so and there are functions inside libraries, but we can write our own if we feel that we need our own personal function. And the idea of a function is that you have some stuff, an input, you put it into a function, and you get something out of that function. So here we've got a little diagram of a cooker here where you put some stuff into the oven and then you get something out of the oven. And it's a nice little way of thinking of what a function is. So you put something in, the function does its work, and then it gives you something out at the end. All right. So yeah, that's kind of the idea of functions, and we're going to use a function now just to kind of tidy up our calculation from the last question, just to kind of give you an idea of how it works. Amanda, I don't know if you anything that you want to mention about functions or anything?
They're just, I suppose it took me a while to get my head around functions when I started learning about them at the beginning, but then when I actually understood them, they're really useful because they mean that, like you said, we can store this kind of piece of code to return a certain output, and it means we can use them again. So the one we do today, Damien, is just a little introduction to functions. It's going to be quite short, but as we go on in code, and what you write actually could be much longer within your function. And imagine being able to have to just reuse that. We can just call on that function instead of having to write that code all over again. So it actually, in the long run, using functions saves us a lot of time, as well as keeping our code shorter and organized.
Yeah, exactly. So if there was a problem like this, where you had to convert from temperatures in Fahrenheit to temperatures in Celsius, but you'd loads and loads of them to do, well, we have a program now that can convert from temperature in Fahrenheit to temperature in Celsius, but are you just going to keep copying and pasting over and over again? Or if we use a function, we could make that just that little bit quicker, that little bit shorter, and that little bit easier to understand. So we're going to try and quickly create this a function to convert from Fahrenheit to Celsius. And then we might try and use it 3 or 4 times really quickly to see how it really shortens up our code and makes it a little bit easier to work with. So we'll take a look here, guys. When we write a function, we put it at the very top of our code. And how we write a function is we have to start off with the keyword def. All right, so def, and then you give your function name. So I'm going to call this a temperature converter. And then you put brackets at the end. Now, sometimes something will go into these brackets, but we're not going to worry about that just yet. All right, we don't really need to know that yet. Now, you can see here that my cursor has jumped in a little bit, and that's because Python knows that this is a function. And anything that's been indented a little bit here is going to be part of the function. Okay, so in this function, what I'm going to do, I'm going to ask the user to enter the temperature. Okay, I need to put quotations on that. Please enter temperature. Okay. And then once they've entered the temperature, well, so I need a variable here. So I'm going to put in temp var here for my Fahrenheit temperature equals to. I'm going to let this just be an input or an integer, sorry, an integer. So the temperature that they enter will have to be a whole number. Okay, so when they enter their temperature, I'm going to have to do a calculation on it. And I actually have the calculation up here. So to save a little bit of time, I'm just going to take this piece of code here and bring this down. So when they enter their piece of code or they enter their Fahrenheit temperature, we'll use this formula and then we're going to print out our temperature in Celsius. So I'm actually going to use this line of code as well, and it'll save us a little bit of time. But if you want to type it out yourself, feel free, pause the video and take your time with it. Okay, so that's my function finished. All right, it's going to do the same job over and over. It's going to ask for a temperature. We enter a temperature. It's going to convert it to Celsius and print out the Celsius. So now I'm not indenting my code anymore. This means that I'm finished with that function. That one's ready to go. And now I'm just writing my normal code. So I'm going to just put in one print statement at the top, print this program converts temperature. Okay. And then I'm going to call the function. So all you have to do to call the function is to type out the name of the function. So I'm going to copy this here and paste it here so that I don't make any mistakes. So what this program will do now, we'll just talk through it before we actually run it. The very first line of code that it will do is this print one here. It skips the function until we actually call the function or type in the name of the function. So the program will write this line first, this program converts temperature. Then it will do this line and see, okay, I need to go and get this function from up here. So it goes back to the top of my code and says, right, I'm going to do all of this stuff now, next. So if we run this here, I get, the first line I get is this program converts temperature. Then it asks me to please enter a temperature. So when it gets to here in the code, it jumps up in here and writes out this line, please enter temperature. So I can enter my temperature, let's say it's 70 degrees in Fahrenheit, press enter, and it converts it to Celsius. So that's how our function works. Now, Amanda, if we wanted to do this, get a couple of temperatures converted, what would I need to do here? Could you help me out to get it to repeat?
Yeah, so we could call on the function again, Damien, couldn't we? So we wouldn't have to write all that out again, which is so useful.
Yeah.
Like those lines of code you just did earlier above, if we had to do that for 5 different numbers, we potentially have to write a lot of code. Whereas now we can just call on it. Yeah.
Exactly right. So here I'm using the function 5 times, and that's all I need to write, because when the program goes and runs here, it'll write out this line first. It will see this, so it'll go back up to the function and do all of this code in the function. And once it's finished that, it'll go to the next bit here and go back up to the function, and it'll keep repeating itself until it gets all the way down here. So this is a very quick and easy way to do the same job 4 or 5 times. And that's why functions are really helpful. If you've got a specific job that you want to do, a function is a really good way of doing it because you can repeat it over and over again.
Brilliant.
Okay.
Great. So we'll recap now, Damien. I think that's a lot of people need to pause maybe while you're still on screen there.
Yeah, that was quite a bit now.
Yeah, it was a lot. So well done, everyone, because we've really moved on now, and you can see we're in week 3, and by the end of week 3, we've covered quite a bit, but there's still loads to do, and there's actually loads of useful things to learn. Functions is probably kind of, we've now built up to a point where we can introduce them, but now you'll see how really useful they are, like Damien said there. And now when we go into our loops and our conditionals, which we will in the next few weeks, again, all of these things make our program much more efficient and much more useful for us. Okay, so well done. We're going to just recap really quickly over the stuff we've learned there today. So first of all, we've advanced our knowledge of using math in Python. So both with our maths operations, but also using our library. So we could import our math library, and we could use that actually for different things too, such as pi, which you've seen there. But there's other functions within that library as well that we can use that are really, really useful. The second thing is, we know now that the libraries are kind of where we have lots of different codes stored, and they really help give us a shortcut, I suppose. I know, again, when I was learning myself, there's lots of libraries, as Damien said, and it saves you having to do all that other work. So we're really actually lucky to have libraries because they didn't always exist. And then lastly, at the very end there, we've introduced the idea of what functions are, and Damien gave a really nice analogy there of the oven. So remember, the functions, they just do specific jobs for us. We put something in and we get something out, and they just continue to do that job for us. But they do condense our code, and they do make it much more organized, and that's going to be so useful for us. And apart from that, as I said, they actually save us time, which is ultimately, when you're doing a big project or you're doing a lot of code, that's really important, is to kind of speed things up and save you some time. Okay. So home challenge, we built out this home challenge to kind of reinforce all the stuff you've just learned there. So what we finished at there is looking at converting Fahrenheit to Celsius. This is very similar, except instead of temperature, we're looking at distance. So we want you to look at converting miles to kilometers, okay? So what we want you to do is create a function, okay? And you might need to look back over what we just did there. You might need to rewind and see what was done to kind of get the memory refreshed. Create a function to convert miles to kilometers. The function, basically what it should do is it should ask the user to enter a distance in miles, and then it converts this to kilometers. And it's going to use this formula. So see in this box down below, kilometers is equal to miles multiplied by 5 over or divided by 8. Okay, so if you use that formula as part of your function, then you're going to get that conversion right. Okay. And these are the different numbers that we want you to convert. So these are the 4 different numbers that we want you to try, but you can try any number really. We're just giving you a set 4 to try out anyway. Now, if you're still a little bit unsure of functions, because I know it took me a while to get a hang of them when I start programming in Python, you could do this out like by actually writing out the formulas and doing it in a kind of a mathematical way without the function. Couldn't they, Damien?
Yeah, so if the functions are proven a little bit tricky, you can just do it step by step, kind of like we did a little bit earlier. So yeah.
Perfect. So feel free to do that if you need, guys. But this again will really help reinforce everything we've done today. So we would recommend you give this a shot. As always, then we recap at the start of the next lesson over this so that you have a really good idea of how it can be done. Okay. So I think that is actually all. There's no questions that I can see there, Damien. So I think we'll actually just wrap up now because we're kind of coming on our hour. So thank you all so much for joining us again. We will be back next week again with episode 4 of Python. So until then, stay safe and thanks to all. Bye.
Bye now. Thank you.